Hello guys, so today we're going to be going over present value and future value calculations. And this is a central idea in a lot of economics based upon the concept of that money today is better than money tomorrow. So to do this, we're going to use two main equations. Present value equals future value divided by 1 plus I, and the return equals P1 minus P0 divided by P0. I personally prefer the present value calculations, not the return one. It's just more intuitive. And the math makes more sense to me, and I find that the return calculation, there tends to be situations where you can't use it, as we'll find in the second problem we do here. So we're going to do two questions. My suggestion is that you pause the video now and you go through them yourselves, and then I'm going to go through them as well right now. So I assume you've paused and tried these yourself. We're now going to do this. So we're going to try first with the first equation. So this is the present value equation. So we know that the future value of this, 1 year from today, is going to be $100. So we plug that into the equation. We know the interest rate. So we have everything we need. This is a pretty simple question. We're going to plug all of this into the equation. I'm just going to add it up because I don't think anybody needs any help doing the 1 plus 0.05. And if we do this calculation on our calculators, we're going to find that the end answer is $95.23. And this makes sense. So if you were given $95.23 today, that would be $100. Oops, I do that a lot, eh? $95.23 tomorrow. We can also do this problem with the return equation. So we just sort of plug things in. We know that the return is going to be 0.05, the interest rate. And we know P1. So this is kind of a what gets confusing. P1 is the future. You could also go P0 is P1 and P1 is P2. So time period 2, as they would say. It's just economic standards that we use. P0, P1. One of the reasons I don't like this equation. But we'll just replace P0 with X for now. We plug that in and we're going to get this equation. And now we're just going to have to do some algebra. And that's going to figure out for us what P0 is, or what the value today is. So if we do that, we get 0.05x is equal to 100 minus x. Once we break this down a little more, we're going to get 100 divided by 1.05, which is actually, interestingly enough, the exact same thing we got when you were doing the present value calculation. So doing this, it's almost a long way to getting to the present value, but all the same, it does get us there. And again, if we punch that into our calculators, we're going to find that we get the exact same answer, $95.23. And I think this is a pretty standard example of the type of question you get on a introductory econ class. But this idea of present value, future value is quite important for that. So now let's go into the second question. Again, pause the video and do this question if you haven't already. So in this one, we actually have to use a present value one. The reason is that it's going to be 2 years, not 1, in which we're going to get this return. And so that means that a return, you could get the percent return based, but that's not going to be per year. And that's not what we want. We want the rate of return per year. So we have the present value is equal to, like we said, 1,000. We just paid $1,000 for it. We're not irrational. We're assuming here. So paid $1,000 for this, and we know the future value is going to be $1,100. And at this point, you're thinking this looks exactly the same as the other question, and that's because it is, and that's because all present and future value calculations use this equation, and they all look pretty much the same. So if you practice enough of them, you're pretty much guaranteed to get it right. But the one thing that we haven't taken into account yet is that it's 2 years. So how do we do that? Well, this equation should actually read more like this. That it should be 1 plus I to the power of n, and n being the number of years. So if we do that down here, we have this equation, but we know the number of years. It tells us it has 2 years from now. So that's good. So we just have to go in, erase this, put in 2, and then we'll have a complete equation on how to solve this. Now again, it's some quick algebra. So all we have to do is move stuff around. And now it's a little bit more complex than it was before. We have to start using square roots and stuff. But I still, again, at the introductory level of econ, I think this is quite reasonable for you guys to be able to do. So we take the square root of this, so we will eventually, once we figure out what this is equal to, and that's going to give us our answer. Now, there's a few things to take into account here that we don't traditionally do. The number one thing is that because this is 2 years instead of 1, like I mentioned before, the return equation is no longer going to work for this. It will get us a return, if we plugged everything in it will give us a return of 10%, which is true. It is a return of 10%. But from there, it's over 2 years, and the tempting thing to do is to say, oh, well, if it's over 2 years, then we're going to get 5% a year. But that's not true. As we see right now, the actual return is 4.88%. And the reason this is because of compounding. So you get paid the 4.88% the first year, and you get that paid again on that 4.88%. So you get 4.88% of that $4.80 or $48.80 you made in the first one. That's all. Thank you.